So again, my usual request to you guys, try to do as much of this on your own. For example, these first ones you should have been able to do. Right angle, acute angle, obtuse angle. Hopefully that was not new, should not have been. Alright, the new stuff. We're going to classify triangles by their angle measures and their side lengths. There's two different ways we classify triangles. Angle measures and side lengths. And then we're going to use those classifications to find angle measures and side lengths. A triangle is a polygon with 3 sides and 3 vertices. Now this first part should be review. You should have already done this stuff. I don't remember, elementary school, middle school, somewhere you've seen this stuff before. An acute triangle has 3 acute angles. An equiangular triangle, do me a favor, put these little arcs right here that tells you that all these angles are the same. The picture didn't have them already. Make sure you put them in there. An equiangular triangle has 3 congruent acute angles. A right triangle, again, put a little box right there, has 1 right angle. And an obtuse triangle has 1 obtuse angle. I think most of us have heard of those before. Okay, now let's do some math here. It gives us a picture. It wants us to classify triangle BDC. BDC. Well, right here at B, I do see a 100-degree angle. That means my triangle is obtuse. Triangle ABD, ABD. It's this small little triangle right here. Now we should remember I do have a linear pair right here. So if this angle right here is 100 degrees, the other part of it must be 80. They do add up to 180 degrees. So I've got 80 degrees there, 80 degrees there, and 20 degrees there. Those are all acute angles. I've got an acute triangle. Over here, we're talking about EHF, EHF. Again, I should see another linear pair right here. If this angle's 60, this one has to be 120 because they do make a straight line. And so EHF has a 120-degree angle, so that makes it an obtuse triangle. FHG, FHG, 60 degrees, 60 degrees. That one also must be 60 degrees. That's an equiangular triangle. The other way that we classify triangles is with their side lengths. Again, do me a favor, put the markings in the picture. They were not already on there for us. Tick mark, tick mark, tick mark, telling us that all those sides are the same length. So I have 3 congruent sides, equilateral triangle. Put double tick marks here, double tick marks here. An isosceles triangle has at least 2 congruent sides, and a scalene triangle has no congruent sides. Alright, what does the math look like? EHF. EHF. Again, I see tick mark there, tick mark there. Those are the same length. That is an isosceles triangle. EHG. EHG. This side length is 12. That one's 11. The bottom one is 14. That's scalene. None of the sides are the same length. Number 4. ABC. ABC. Well, these two are the same because they each have a tick mark. And these two are the same because it says they're both 15. That means they're all 15. That's got to be an equilateral triangle. And ABD, ABD, scalene. None of those sides are the same length. Now we got some algebra to do. Surely you saw this coming. Tick mark, tick mark. That means these are the same length. So I can do 4x minus 10.7 equals 2x plus 6.3. They each have a tick mark. They must be the same length. Do a little algebra, subtract 2x from both sides. Gives me that. Add 10.7 to both sides. Gives me 2x equals 17. Slide this up so you can see. Divide both sides by 2 and you get x equals 8.5. So x equals 8.5. To get JK, just plug in 8.5 where you see x, and you'll get 23.3. Take the time, instead of just assuming that KL must also be 23.3, it should be if we did our algebra right. But take the time, put in 8.5 on this side too, and make sure you get the same answer, because that's a good indicator to you that you did your algebra right. And you should get 23.3. And JL, across the bottom, put in 8.5 for x, and you'll get 44.5. This one, they tell you, given that you have an equilateral triangle, find the following. They want to know all this information. But if it's equilateral, all the sides must be the same length. So just pick a pair, pick some sides, set them equal to each other. I did 3y minus 4 this side equals this side. Didn't matter. I could have done that one equals that one too. I just chose those two. Minus 2y both sides gives you that. Add 4 to both sides. Y is equal to 7. Right there. And then all these must be the same. Plug in y equals 7 and see what side length that you get. Next thing we got to go over, interior and exterior angles of triangles. Find the measures of each. And then we got to apply theorems about interior and exterior angles of triangles. This first one we've talked about for a while now. If in any triangle we'll talk about in this class, if I add up all the measures of all the angles, measure of angle A plus B plus C, it always equals 180 degrees. We've done that one before. This is the new one. If I've got an exterior angle, see I've got 1, 2, and 3 are on the inside of the triangle. Angle 4 is on the outside. That's an exterior angle of this triangle. But this exterior angle must equal the sum when you add up the two remote means further away, interior angles. So add up angle 1 plus 2 and it will equal angle 4. Measure of angle 4 equals measure of angle 1 plus the measure of angle 2. Whenever I have an exterior angle of a triangle, I can add up the two angles furthest away from the exterior angle and it will equal that exterior angle. So now of course here's some practice for us. It wants to know the measure of angle NKM. NKM is right here. But it is in a triangle. If these two are 88 and 48, I can add those up. It gives me 136. And if all the angles of a triangle add up to 180, subtract that from 180, gives me 44. So NKM has got to be 44 degrees. Next one they want is KMJ. KMJ is right here. Notice it's got an arc. And the one we just found also had an arc. That means they must be the same. So KMJ must be 44 degrees. And MJK is right here. That's got to be 32. Why? Add up 44 plus 104, subtract it from 180, that one's got to be 32 degrees. Pause again, pause. Make sure you can do this on your own. It's a good way to practice. X, what is X equal to? Well, I've got an exterior angle, so I can do 58, this angle, plus this one, plus X plus 12 equals 110. X plus 70 is equal to 110, minus 70, X equals 40. And you can do this a few different ways. You can also say, you know what, this makes a linear pair, so that makes this one's got to be 70. So I can do 70 plus 58 plus this one equals 180 degrees. That'll work too. There's usually more than one way to do a math problem. Do the way that makes sense to you. ABD, I don't know why they asked for that. It's right there. It gave it to you, 110 degrees. Measure of angle C has got to be 52 because 58 plus whatever this is has to equal 110. My exterior angle equals the two remote angles added up. And this is a pretty common question. The measure of one of the acute angles in a right triangle is 63.7. What is the measure of the other acute angle? Well, all triangles add up to 180. If I've got a right triangle, it means I've got one angle that's 90 already. So I've got another 90 to split between the other two angles. So if one of them is 63.7, the other one's got to be 26.3. And here's how that works. So here's my right angle. It tells me that one of my acutes is 63.7. So that means these two must add up to 90, because this one's already taken up 90 degrees. If they all add up to 180, these two must also add up to 90. So when I add it to this 90, it does equal 180. So all I got to do is 90 minus this angle right here, and it gives me 26.3.